because we're about time, so we're going to start.
Yep.
My name is Kendall. I'm a CLD. I've been developing LabVIEW for almost 15 years now. I was an undergraduate physics student, and Jared and the other NI guys sold me some hardware, and I learned LabVIEW on my own, and it was messy and it was bad, but it got me started and it got me my first job. I've worked at a company called Seattle Safety down in Kent. They built crash test equipment for car companies. I was at Xbox for about 5 years. I just finished a year at Fresh Consulting, and I am on a break currently, waiting to start a job at Blue Origin on Monday. So that's my background. In addition to that, I did learn GIT through Microsoft training courses when they did the transition a few years ago. So that's where the majority of my formal training in GIT comes from. And then the rest of it I'm self-taught, as I am, like I said, I'm a physicist who's becoming a hardware engineer and software engineer. And so, like the rest of us, I have a fun background, and I get to mesh all those things together and try and learn the parts that I don't know yet. And good workflow practices and source control is one of those things. So, GIT and LabVIEW, or how I learned to work with others instead of working around them. This is kind of, this comes from a lot of my experience having been a developer on a team. And one of the problems has always been, how do you work together? As a very, very junior engineer at Seattle Safety, I inherited a very large code base that was done very quickly by a very smart person. And they wrote code like that. And it took me about 5 years to sort out, and I never really fully sorted it out. But one of the things that I kind of did, as I was more in charge of the generalized architecture, was there was a really smart PhD in signals, and she did the primary algorithm development for what we call the fire loop, which was the main test part, which was about a second of really scary, terrifying math. But we hid all of her code in one VI, and just were like, I'm just not going to look at that. And so that's not the way to do things. It's taken me years to come, like, figure out how to do things right, and I'm still learning. And like, you should all be learning all the time, and learning how to properly use source control and work around others, or work with others instead of around them, is your thing. So technical considerations about using GIT, and so we're going to get specifically into why to use GIT, why not to use GIT. So you may be familiar with, most people use SVN. In the LabVIEW community, Perforce has also been widely used for years and years. Reasons to use GIT over any one of those options: the ability to commit to check out previous and check out previous versions locally without access to a central repository. Good if you're doing on-site work, or if you're behind like the Great Firewall of China. I know that I hate having one giant check-in that represents 3 weeks worth of work. I've been in a factory in China. I've done 3 weeks worth of work, and there's literally one check-in for the whole thing. There's no checkpoints. There's no, 15. These are the 25 steps that it took me to get to where that final software is. Pull requests as code reviews are possible without cloning another copy and removing what you are currently working on. And another thing called branch swapping that we're going to get into that's super useful if you're doing large-scale development. Better branching tools than other version control systems are available. It does come with a learning curve, so there's that. Reasons not to use GIT: merging code is not as smooth as text languages, and can be a time-consuming process, and I'm going to address some of the tools that you can use to make that a little easier. The lack of native support in LabVIEW development environment for, I know that SVN, they've got the plugin, so you can tell when you're checking things out. You get a little pop-up where you can do a commit within that. And then the big one that most people are going to hate is you cannot lock files in Git. You can have multiple developers working on the same file at the same time. This sounds like a bad thing. It's actually a good thing, but we should talk about some of the ways to structure your code to get around this problem. And part of that is going to come down to like how tools affect architecture. There are also human considerations for using Git. Git has become the standard version control system for many workplaces. Frisch Consulting was like that. They had a large digital arm, mostly did websites and such. And so Bitbucket was their primary provider. So the LabVIEW group, which was absorbed into that company about a year ago, started using Bitbucket, and there was a little bit of a learning curve for those of us who hadn't done it. Branching allows for parallel development by teams on branches without changing production code. You can run experiments off in a branch. You can say, hey, this is an idea, let's go run this experiment. You can have multiple people working on that same code base without affecting code that's, say, going into a production environment. This is especially critical when you're working in the medical device field. Philips is one of Frisch's large customers, and you do not change things in the medical device field unless you've gone through a very large book of procedures. So other reasons to use Git, your boss told you to, and that may just be like, that's all that's available. That's the only license you're going to get because that's all we have budget for. Reasons not to use Git, there is a steep learning curve if you have used Perforce or SVN. It is a very different mindset, and we'll get into that in a minute, and how to change your brain to start thinking about it in a different way. I like it, but I've been using it for years, not only for my work, but I've also been using it for personal projects, including just writing. Like I keep all this, like a lot of my writing that I do in a Git repo in Markdown form, and I find it easier to use, navigate, and version than using Google Docs. I don't know why, maybe my brain's weird, but it's weirdly, I use it for resumes. You can branch and merge and make selections in resumes. It's kind of a weird idea, but it works pretty well. Other reasons not to use Git, you do have to talk to your coworkers because you've got to make sure that you're not all working on the same file at the same time. General reluctance to change, changing from an old thing to a new thing is all this stuff. There are a lot of tools available for Git. It is the version control system for digital developers, websites, games, you name it. Everybody uses Git. It is an open source product. It is free to use. You just download it. Now you do need a central repository, which you can either run on a server on site, which takes some setup, or you can pay a little bit of money to a cloud provider, GitLab, GitHub, Bitbucket, you name it, they're out there. There's 100 of them. They're cheap, they're easy to use, they're pretty much interchangeable. Don't worry about it. Now you're also going to see that there are a lot of GUI interfaces that people have created for Git. I don't use any of them. I hate them. I use the command line. I love the command line. You should also use the command line. You should use bash. You can write scripts. It's basically a tiny Linux environment that runs in Windows, and you can run all your tools right through the bash. I find it doesn't actually slow me down in the long run doing it through the script, or through bash. What it does is it makes you take that extra half of a second and think, do I actually want to add that file? Did I make a meaningful change to that file, or is that just a type def updated? Or I accidentally looked at that file and I accidentally hit Control S, and I didn't actually make any changes. I'm going to concentrate on using the bash script for interacting with Git. I think that most people should learn it that way first. You can use the GUI tool later once you have in your brain how the flow works and what exactly you're doing. Because as you'll see in a second, things don't work the same way. The verbiage is a little different in Git than maybe with Perforce or SVN. So, tools inform process. There's basically a centralized repository, and this would be, Perforce would be a very good example of this. There's a working copy on each developer's machine. There's a central repo. They check out a file from the repo, they edit the file, they check it back into the repo. They have a local working copy of all the things. The difference with Git is when you say git clone, which is basically the first operation of, hey, I want all the code from this repository, you get the entire repository. You get all the history, you get all the previous versions. Like you were talking about, binary files get to be an issue very quickly. But they've actually been dealing with the LabVIEW binaries very well recently because they do a bit for bit diff. And I haven't had one corrupted in a long time, so you might want to check it out. They've made some significant improvements. Okay. But you get an entire local repo. You can roll back to a previous version locally without access to the centralized repository. If you're sitting on a factory floor in China and you forgot what you changed a week ago, and it was working a week ago and it's not working now, you can roll back without having access to that centralized repository. That is a huge win. And I've done that more times than I can count. It also gives you the ability to do local branching, where you can branch, make like 3 different branches in your local repository. They're never uploaded to the central repository, but they're just like, hey, I have an idea. I want to try this idea. I want to try that idea. I want to try that. Oh, that's the one that works. Merge that one in, kill the other 2 branches. It allows you to iterate through ideas a lot more quickly, at least I find. And it does take some getting used to, and it does, you have to stop thinking of like your working copy as static. Your working copy becomes fluid because you can swap between branches, and we'll get into that here in a second. Like I said, there's a different vocabulary when it comes to Git. There's not just a remote repository, there's not just a workspace, but there's an index and a local repository. And so you're constantly keeping these things in sync. It sounds like a lot more steps, but honestly, there's pretty much only 5 commands you ever use. So first one is pull or rebase. That is basically you are synchronizing with the remote repository. You go git pull, it pulls what is called the origin, or the very front of the repository. That includes all the back history to it. So the git pull is generally going to be the first command you're going to use. Say you're going through a typical day of workflow, you pull down the latest, and then you start editing. So once you start editing, you're editing the workspace. You're not editing the index or the local repository, but you're kind of existing in a gray area. Nothing has been changed in the local repository until you tell it to. So there are basically, well, there's 1 or 2 steps. I always do it as 2 steps. Add is where you're saying, here are the files that I changed. The great thing is Git keeps track of what has changed since you did the last pull, or since you did the last checkout. And it will automatically generate a list. Here. Nope. Gotta move that over. So what you do is you go git status, on branch, new topic, nothing to commit, working in a clean tree. So you've always got this kind of idea here, or this this tool here that's telling you what you've changed, if you've changed anything. This screen setup is not great. So basically, you have to start thinking about moving between the different levels in the hierarchy. You're pushing things, don't use the word push, you're adding things from the workspace into the index. The index is the staging area, and that's essentially you going, is this the change that I actually want to make? And then once you are sure that that is the change that you want to make, you commit it to the local repository, and that's essentially a local check-in that goes, hey, I've made a change. That's where you would comment your change in your commit, and then you can, at that point, either continue developing, do more add, commit, as you develop, or you can push it to the centralized repository. And you'll have to figure out how to do that with your own team. And I know there's a lot of different schools of thought on that. You should be committing every 2 to 3 hours to the centralized repository, or you do all your work for an entire day, you commit it at the end of the day, or there's branching workflows where people work on different branches for weeks at a time, and then at the end of that, they come together and have a merge fight. But yeah, so it's a very different vocabulary, and I've got, I've put together a cheat sheet for LabVIEW developers on how to use Git, basically workflows, basic ideas behind the system, and that's actually all up on GitHub, and I will provide you all with the link to that. It's in this presentation, and I'll make sure it's in the notes that Jared distributes. So you're saying to yourself, I'm an individual contributor. I don't work with anyone else on the team. Why would I use Git? Why wouldn't I just use SVN or Perforce or just put everything on a server? Yes, it's easy, but I think this kind of workflow illustrates what using source control properly can do for you. So in this scenario, you are going on a trip to China, and you're getting progressively more sleep deprived, and maybe you've got food poisoning by the end or something. Maybe pulled from real world events. But you create a branch, you say, I'm going to China, I'm doing this thing. The nice thing about that branch is you can do what's called branch swap, and I'll show you how to do that in a minute. And you can basically go immediately swap back and forth between the code that you've done in the factory and the code that you've done back at home. You can go, what changes have I made? You can do a diff, master to the new branch. You can just automatically have those files diffed and look at, and you can find where you've broken something that was previously working. And so you've never touched your central repo. You can literally have, they can have, disabled your Wi-Fi. You don't have Wi-Fi at the factory, whatever, don't care. You will have check-ins that may or may not contain the best code comments, but you'll have at least some record and some iterative process and say, oh, these steps were made, these changes were made in this order. And you'll have some record of that. And then once you merge it back into the main and push it to the remote repo, you can be home and finish with your trip. And it kind of creates a logical separation of the workflow. Now, this gets more complicated when you're working with a team. You have one member of the team, they go off to China, they do a bunch of stuff, and you've got a person in here working on new features for the same code base. They're over here in the States making changes while the other person's in there. You are going to hit a point of conflict. Now, with proper code structure, you will have separated different your code into logical modules, and the OOP guys later in the afternoon are going to get into this, but how to separate your code so that by editing one thing you don't affect dependencies on everything else. But let's say two developers edit the same thing, there is going to be a conflict in that merge. But for the most part, like if you end up editing completely different files, so this guy, he's working on adding logging support, so all he's touching is the logging files, and all this guy is touching are the files having to do with a particular test process. Maybe those pieces of code never interact, and so when you merge, the new VIs, they go in the right place. The two developers have never touched the VIs that the other developer was touching. Boom, no problem. Goes together, not a problem. The problem gets when your code is highly coupled. If you have global variables, if you have highly coupled type definitions, if you share functional globals across large amounts of code, you are going to be in a world of hurt real quick. And at that point, git merge starts to look a little more like that. And I have actually seen teams, and this is even working in text languages, this was specifically in C#. It took us about 4.5 days to get a merge worked out at Microsoft one time. We were building test harnesses into part of the Xbox system, and like I'd made some changes, another guy had made some changes, another guy had made some changes, and they all had to be merged together, and it just took a while. And you had obviously had to go back and do regression tests on everybody's particular thing, but it can be a nightmare even in text languages. But it doesn't have to be that way. You can use it as a good time to talk to your teammates about what they're doing, why they're doing it. And ideally, you do that in a structured way. You have rules and process in place. You bring in a third-party arbiter. Maybe they don't have to be a LabVIEW developer. They can be another developer or your company, a PM, whoever. Because sometimes when you have to explain things to people from outside, you stop and you think and you go, oh, okay, I'm wrong, I'm sorry. And just having to think about it, it is one extra step in the process, but it will save you time in the long run. Because you're stopping, you're thinking about it, and you're making better decisions as a team by having a discussion as to why you were doing things the way you were doing them, and why it caused conflict, why it caused a merge conflict in the first place. Style guides, if you don't have one at your company, you should write one. If you're an individual contributor, you should write one because it helps to be consistent with yourself. And yes, your past self is never consistent with your future self because you should always be learning things. And sometimes I check out code that I wrote 2 years ago and go, oh my God, what idiot wrote this code? And then I look at it and I'm like, but that's how it goes. Again, avoiding merge conflicts. Code that is not highly coupled will result in far fewer merge conflicts. Shared code being minimized. With Package Manager, you can use VI packages, and if your team uses the same packages in all their projects, and you ship internally libraries that you reuse over and over and over again, those aren't included in the repository, they are rather included within your VI lib section. This can get to be a little bit of an issue if people have differing versions of those VI packages. That's why one of my hopes for NXG is project-based package management. Basically, I would like an include statement for LabVIEW, something that we've never really had for outside packages. Currently, you just have whatever package you have. Okay, so I'm sure what we're all wanting to do, this is a miserable setup for this, is the actual demo. So what I have, wow, this is no fun.
screen. Oh, no, you're not. There you are.
Excellent. So, we're going to go through a typical workflow. What I have already done here is I've created a local branch. And you can create a local branch in a couple of different ways. GIT, branch, new, you can, there's a bunch of different ways, and actually my GIT cheat sheet has all of them in there. Actually, we'll GIT and also, one thing to note, the latest version of GIT, if you download it with the bash, it has autocomplete. Tab is your friend. You can write the first 3 or 4 letters of a command, and it will autocomplete the rest of it for you. So what I'm going to do here is what's called, this is the thing we were talking about earlier, it's called branch swapping. And I'm going to show you, this is just an example VI. So, new example VI, blah, 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 there's that block diagram. And what we're going to do now is we're going to and you'll see this is a 20 instead of a 10, basically, was the only change that was made. Now, basically, here, the problem is always going to be when you go to get these 2 branches to match with each other. Now, the nice thing is there's an LV merge and an LV diff tool that ship with LabVIEW. The problem is they do not natively accept bash style / paths. Someone on the internet, I think he's an NI employee, was nice enough to wrap those tools in another set of tools that rectify the paths and make the paths go from, / Linux style file paths to Windows normal / pathing. So it's kind of a weird system. Anyway, so what we're going to do here is we're in the master. We're going to go, okay, we've got a 20 there, and then we're going to go check out. Sometimes maybe I didn't make that change. So we're going to make a more obvious change just so that
you had another control front panel.
Oh, that was the change I'd made. Thank you. Well, actually, if we want to skip ahead a little bit, we can see what the merge looks like, and that'll actually show us more. So, I'm just going to make a quick change there. So, I forgot to save it. So once I save that, you'll see that the new example VI shows up in my list of changed files, and that's GIT basically looking out for me going, hey, you changed a file. Now, if I didn't change that file, I may not want to check it in. So this is the add step. This is me deciding what items I would like to add to my next check-in, to my next commit. and really start to try and use different words than check-in, because checkout means a different thing in Git than it means in Perforce. And the online community, and there's a ton of info on this. You're talking millions of developers around the world use Git. You got a question, some Python developers, some C++ developers had the same question. It's on Stack Overflow. It's your friend. That's actually the great thing about having a big development community out there. Somebody's run into this problem. And I'm a huge open source advocate, which is weird because I'm a LabVIEW developer, which is one of the closest languages ever. But I really think that we as a community should do a little bit better job of being open source. And if it's a problem that I've had, it's a problem that you've had probably as well. And if we can work together to solve that, everybody does their job better, and we all get more work in the end because more people come to us for solutions. Anyway, so I've got 2 modified files here, and git add. Now there's a couple of ways you can do the add. One way you can do it is you can do it by file name. The other way you can do it is a -a. That is all changed files that are in the workspace will be added to the index. And then the other way you can do it is just with a dot, and the dot adds all changed files that are at this file location or lower. And again, that goes back to like being able to use and navigate the bash environment. You're probably going to want to brush up on your Linux commands, cd, change directory, ls, list something. I forget what that stands for, but it's basically dir from Windows Bash. Windows Bash for Git has been deprecated. It does still exist, and it does still install with the current version of Git, but it is considered a deprecated product. I don't use it, but it is still there if you've got CMD scripts or anything like that that you want to use in conjunction with Git. But that's a whole different topic. Anyway, so currently I'm just going to add everything that's been changed. And now I'm going to go back to Git status. And they've changed from red to green, or so I've been told. I'm colorblind. But so basically these are staged for change. They're sitting in the index, waiting to be committed to the local repository. And then to commit, so I always do the -m option, and that's basically, I put in my commit note right into the command line, and I'm going to show you what happens when it doesn't. It's going to open this thing, and you type your commit message in, and then save, and then close, and then it goes back through that. It's not so bad if you have code set up, or Notepad++ or whatever, but if you're not used to Vim, which is the default Linux text editor, it can get a little hard to navigate. The first time I got stuck in Vim, it took me half an hour to get out of it. But you'll figure it out. It's pretty easy, but like I said, my favorite is the commit-m. This is my message. I'm going to get an error here, but nothing to commit because I'm working a clean tree. I've already committed that the previous time. So I'm going to go with git status again. Nothing to commit working on a clean tree. Basically, once you commit it to the local repository, it's locked in. I'm considered in a clean tree. Now, we know that there's differences with the same file between main and the topic branch. So we are going to merge master. So it says warning, cannot merge binary files, blah blah blah. Auto merging, conflict. So basically, you'll notice here this thing in the parentheses on the side. That always tells you where you were at in the particular repo, whether you're on the master branch, a local branch, a remote branch, or in this case, it shows us we're at new topic and we're merging. So we're currently taking place in the merge operation, and if you want to at this point, you can go, oh, I didn't mean to actually merge. You can go git merge abort. Merge abort will basically back you back out, and that's like, oh, I didn't mean to check that file in. His file is actually the right file. There's other ways to deal with that at this point. So there's a lot of different ways you can deal with merge conflicts, and you'll eventually learn them all. This is going to be the easy way, but actually the easy way is you do git merge x vars, and you basically just accept everything that's in the remote. Like, let's say you weren't actually trying, you don't care about the work that you just did, and you just want a local copy of it. That'll bring you back up to date with whatever's ahead. Anyway, so we're gonna do it using the tool now. So there's a thing called the merge tool, and I'm gonna go into how this is set up for LabVIEW here in a second, but here's basically how it works. Pull this sucker up. So you'll see theirs, this top theirs always means the remote repository, or the local repository, the branch that you are trying to merge into. In this case, the master branch is theirs. The base is essentially what is held before the master branch. Their current commit, or the base is actually before the topic branch and the master branch separated. It's whatever existed before that, the original VI, before the two were separated into different branches. And then yours is obviously what the contents of the branch that you are currently working on, that you're currently trying to merge. And you'll see this tool is pretty cool. It shows all the different differences in the VI. It's showing, I've got a slide, I've got a new front panel object, I've got wiring changes, I've got a new merit constant data value, and basically just goes over all the different differences. Now, where I think this tool will be really useful is you've got a team in a room, and you say 2 or 3 of you have been working on a project, and you need to merge everything back together. You can put this up on a projector, and you can all talk, and you can go, which one of these changes do we want? Do we want, do we want to change this value? Do we want to change the wiring? Do we want to add this indicator? That's really what this tool is for. It's to facilitate being able to take multiple pieces of code and stick them together. And you basically just, it's creating a merged VI over here on the side. Once you're done selecting, yeah.
Is this for functional changes only that shows, or will it show if you like reposition something, will it also show changes? Is that front panel repositioning, back panel, like does it show?
It'll show repositioning, yeah, unfortunately.
Okay, so if you move stuff on any panel, then
yeah.
you
Which,
have a lot of
in
changes.
that case, I would actually back out. I would do a merge abort, back it out, and then like make sure it's a real change.
Yeah.
Like if you've accidentally, hey, I moved something because I was looking at it, that happens, you back that out. Or the other thing you can do is you can accept theirs. So there's the option to do just take a theirs, or one thing that you can also do is when you do get merge, It's just say theirs and then specify what file, and just take their file. You maybe you want to merge like one of the two files that was changed. You can do that in merge tool. The merge tool will also only act on one file if you ask it to. So you can merge file by file, and you can go, oh no, I don't want to merge that one, back that one, back it up.
Yeah.
It's like I said, it's a little tough to get used to if you're used to doing it in like the Perforce way, and the check in, check out. I don't know, what do you use?
Nothing so far.
Okay, well, realistically, I'd say go through some of the basic YouTube tutorials on using GIT for any other language. And then I'll put out the GIT for LabVIEW stuff. And it's, once you get your head around moving between branches, what the index is, what the local is, what the head is, what the origin is, and how those all relate to each other, it'll start to make a little more sense. The merge tools aren't the best. Like I said, even in a text language,
Yeah.
you can spend 4 days merging things. And I kind of think that's actually a good thing. It gives you and your team a chance to do regression testing. You make good decisions. Even if you're working as an individual, it causes you to make that 1 extra second think, why did I do that? Am I going to hate myself in 6 months when I check this piece of code back out and go, oh damn it, I wrote that, didn't I? I'm a firm believer in the philosophy of going a little slower to do things right, and I think that's what source control enables you to do.
Is this available just for Git, or is this a merge tool you can use with any code repository?
Say again?
Is this merge tool, is this just work with Git?
It'll work with anything. It's actually command line based, and I can give you some of the info. It takes a little bit of special setting up to get this into it takes a little bit of special setting up to get the LV merge tool into Git. Obviously, if you don't have it configured properly beforehand, Git will reject trying to merge two binary files, as it should. And but what instead I have done is I've gone into my Git config, and I have pointed it to these LV merge tools, and those are just essentially command line tools that will take in all the different file paths that get feed it. I'm sure Mercurial or SVN have similar things.
But the merge tools are just ones that you can download from NI?
They actually install native with LabVIEW.
Oh, okay.
Yeah.
I think they're only available with a professional license and above.
Oh,
I got nailed by that a few years ago.
really?
Yeah, I bought the base license and then a whole bunch of extra packages. No diff, no merge.
So,
So it's actually cheaper to buy the platform bundle.
Where is my, where is, so this is actually an open source project that's on GitHub. I'm not sure if this guy is from from National Instruments, but this is a VI compare. This is all the source to the VI diff and VI merge.
Really?
Yeah. In addition to fixing the file wrapping, and I'll put a link. There's a link to this and how to do the whole setup in Git in my notes that I'm going to email to everybody. But it's once you get the hang of it, like once you get that hurdle crossed, once I figured out how to edit my Git config file properly to get it the right file path, it was easy. No one had put together documentation on how exactly to do that outside of source tree, which is Bitbucket's GUI for editing, or for doing Git. But I just bypassed that and put it directly into the Git config file. Now there's differences between a global Git config file, a local repository-based one, and that's in my notes as well. But yeah, these tools are pretty easy to use once you kind of wrap your head around how the system works. And this thing is you just download this, compile it for your version of LabVIEW, and you're good to go. But, yeah, pretty easy stuff. Anyway, so do you want to save the merge VI? Yes. So now it shows that the VI that we merged using the LV merge tool has been modified. So you're asked to commit it one more time. And that is essentially one extra step where it wants you to put in a note saying, this is what we merged, this is how we merged it, this is why we merged it the way we did. So there is a little bit of like, are you sure kind of nature to it, as in it's always going to, it always wants you to go, hey, what'd you do? I know Perforce is like this, where, or at least depending on how you set your server up, it won't let you check things in without a comment. And that's essentially what it wants here. So git commit. So now we've merged it, and essentially both the master and the new topic branch are the same at this point. So the final thing that you should know is we've made all these changes. We've done branching, we've done diffing, we've done all that. We still haven't uploaded anything to our central repository. We can work for weeks on the local computer. Obviously, you probably don't want to do that because then you don't actually have a backup to anything. So the final thing is always git push. And basically all that does is that is another series of diffs, and that diffs your local version of the repository, and that's the entire repository. It diffs your entire repository versus the entire repository that's sitting on a remote server. If there is a conflict there, you'll get an error. Say someone's made some edits. What you then need to do is what's called a pull, and that pulls down the changes that have occurred on the remote server. And I'll go back to PowerPoint.
That happened many times, that my workmates made commit end of day something, and he sent email that you are able to build now because I commit all.
Yeah.
Morning I check, no, there is nothing, but because he didn't.
Oh, he forgot to push.
Yeah.
Yeah, he
Just
committed.
Yeah.
Yeah, don't just commit. You have to push. Yeah.
Maybe not anymore, but year ago that happened so many times. I said,
Yeah.
did you also push?
Yeah, and
or add, if you don't remember to add your new VIs.
yes.
If you need to add some sub VI, if you don't remember to add, you only comment and push.
So my trick to double checking that I've actually done what I said I did, before I tell my colleagues on the team, hey, there's new code, you should pull. I actually open up the web interface to, you know, whatever source control server you're using, and you will see a list of commits, and when you then go, oh yes, I actually made a commit. This reflects only the commits on the remote repository, and Bitbucket has this, GitLab has this. This just happens to be GitHub. This is what I had pulled up, but yeah.
So it's
Git-
not done until you see it on the web interface.
Yes, it's not actually up in the cloud, or whatever. Yeah, whatever you're using. If you want to set up your own Git server, good luck. Yeah, we're done.
We're done, yeah, we're out of time.
Okay. So, Jared, are we going to have notes for all of this posted on the web?
So making a video,
Awesome.
that will be, email will go after this with where you can view the video.
Okay. So, I have complete instructions on how to set up the LV diff and LV merge, along with examples, up on my personal GitHub page, and as open source. I would love people to add documentation. One of the things, it's just a bunch of markdown files. It'll get you set up and running in about 10 minutes, as well as some examples. Yeah.
Did you say that you were going to have, you were going to email us all?
Actually, I can put a link to your page in the follow-up email.
Yeah.
I'll do that.
That'd be great.
Yeah.
Okay.
Perfect.
Otherwise, come bug me and I'll give you my email and we can chat. I will also post it on the Seattle area LabVIEW user group forums. So.
Have you made